Hello, and thank you all for being here this morning. My name is Indrani Malhotra, and I'm a double major in Environmental Analysis and Policy and International Relations. Today, I'll be presenting my Kilachand Keystone project, titled Is Climate Finance Worth the Investment? Assessing the Efficacy of Energy-Related Climate Finance. For this project, I was advised by Dr. James Baldwin in the Department of Earth and Environment, and would also like to thank my dedicated research partner, Jalen Carr. According to the 2021 report from the Intergovernmental Panel on Climate Change, the world is currently on track to exceed the 1.5 degrees Celsius of global warming deemed safe by the end of this century. We are already seeing the impacts of climate change today in the form of more intense heat waves, devastating wildfires, and stronger storms that were once considered to be once in a generation, now occurring multiple times in just a year. And much of this can be attributed to the release of greenhouse gases such as carbon dioxide due to the burning of fossil fuels for things like energy. Developing countries, which historically bear the least responsibility for the greenhouse gases that are causing the emissions that we see today, are the most vulnerable to the very worst impacts of climate change and the least equipped to deal with its effects. Climate change is not only the biggest problem of our time, but the biggest injustice of our time. Something that has been proposed as a new and sort of innovative solution to climate change is something known as climate finance, which brings me to the topic of my project. International climate finance, or as I may sometimes abbreviate it, CF, is the provision of money from wealthier countries in the global north to developing countries of the global south for purposes of climate mitigation, which means addressing the root causes of climate change through things like renewable energy and reforestation efforts, or adaptation, which means responding to the inevitable impacts of climate change by boosting readiness and resilience. Climate finance can flow through multiple different sources. It can come from either public or private investments and come through channels including governments, development banks, public-private partnerships, or private investments. The mechanisms vary from things like grants and loans to money markets and bonds, but at the end of the day, the goal is that target countries receive investments for projects which boost both national and international climate mitigation and adaptation measures. Due to international agreements and a growing attention to inequity, climate finance has gained traction as an idea in recent years. In 2022, climate finance allocations reached an estimated 1.3 trillion US dollars. This may seem like a lot, but research shows that climate finance needs to increase by at least a factor of 6 by 2030 in order to avoid global tipping points. By 2030, it must reach an estimated 8.5 trillion US dollars and continue to grow to 10 trillion US dollars per year by 2050 to avoid that threshold of 1.5 degrees Celsius. There is a growing body of academic literature that looks at this gap in climate finance, as well as the determinants of why some countries receive more than others, but less research has actually been done to look at whether or not it works. Determining the efficacy of climate finance really is essential to making world leaders understand its importance and be willing to amp up contributions. So my research aims to contribute to this growing body of literature. Which brings me to my research question. We asked, is global climate finance for renewable energy projects correlated with decreasing carbon dioxide emissions in countries who receive climate finance? Going into this project, we expected that countries who had received larger allocations of CF for renewable energy would see a greater reduction in emissions of carbon dioxide compared to those who had received less money. We used carbon dioxide as the primary variable with which to measure the efficacy of climate finance because it's widely known that carbon dioxide is the primary greenhouse gas contributing to anthropogenic climate change. We also chose to look at climate finance specifically for renewable energy projects because renewable energy is considered to be one of the most important mitigation strategies that we have to solving the climate crisis. We looked at climate finance for renewable energy projects that included 7 different types of energy. So those were solar for centralized grids, wind, biofuel, geothermal, hydroelectric power, marine energy, and a broader categories of multiple technologies. The climate finance money flowed through mechanisms including equity investments, official development assistance as grants, official development assistance as loans, as well as other official flows. We also accounted for various control variables that are either known to impact carbon dioxide emissions or that we thought might have statistical importance in the model. So those were energy intensity, gross domestic product or GDP, population, a measure of climate vulnerability, which I might sometimes refer to as an ND gain index, as well as a measure of electricity access as the percent of a country's population with access to electricity. The data that we used came from the World Bank, the Organization for Economic Cooperation and Development, and the Notre Dame Global Adaptation Initiative. Our sample included 119 countries across a 16-year time span from 2004 to 2019. Indicated here on this map, you can see all of the countries that were included in the sample, color-coded according to their per capita income level according to the World Bank. So in blue, we have low-income countries. In green, we have low middle-income countries. In yellow, we have upper middle-income countries. And in red, we have high-income countries. And these were the countries that had received allocations of climate finance specifically for renewable energy within the 16-year time span that we were looking at. We chose 2004 as a start year because there wasn't a ton of climate finance activity happening before then, and we decided to end the study in 2019 to avoid any potential disruptions due to the COVID-19 pandemic. Our first methodological step was to visualize some time trends. So in the blue line here, we can see an increase in carbon dioxide emissions over time. In the red line, the red dashed line, we can see that climate finance has generally also increased throughout the study period, but has far more variability than the emissions data. Looking a little closer at climate finance specifically, we can look at average allocations of climate finance by those income groups that I mentioned before. So the highest intake was by low middle income countries, indicated by the green line, and the lowest intake overall was by low income countries, and this is likely due to the lack of infrastructure to actually make those investments into tangible projects. We can also observe a noticeable spike in about 2015, 2016, due to the signing of the Paris Climate Accords, which are widely considered to be one of the most influential climate agreements of all time. We then created a generalizable statistical model for carbon dioxide emissions. So we used cross-sectional time series modeling methods under a fixed effects estimator to create a model for carbon dioxide emissions as a function of climate finance, specifically for renewable energy, and those control variables that I mentioned before. So energy intensity, GDP, population, vulnerability, and electricity access. The little IT next to each variable represents that we are looking at each specific country in that time span of 16 years. Due to differences in something called stationarity, we ended up having to difference a few of our variables. Taking a difference essentially means that instead of looking at the level of that variable in a certain year, you're looking at the change from one year to the next. So our final model ended up predicting the change in carbon dioxide emissions from year to year as a function of climate finance, energy intensity, the change in GDP from year to year, the change in the growth rate of population, and the change in that vulnerability measure. Climate finance had a statistically significant and negative relationship with the change in carbon dioxide emissions, meaning that as allocations of finance went up, the change in carbon dioxide emissions went down. Energy intensity was also statistically significant but positive, meaning that as energy intensity increases, the change in carbon dioxide emissions increases. The same is true for GDP and the change in carbon dioxide emissions. And this makes sense because as countries industrialize and gain more gross domestic product, they tend to emit more. As the growth rate of population increased, the growth of carbon dioxide emissions also increased. And the same is true for the ND gain index, which was that vulnerability measure I mentioned before. Electricity access was not statistically significant in the model and was removed to improve model fit. So what does all this actually mean? The main conclusion here is that our hypothesis was correct. As climate finance for renewable energy goes up, the growth rate of carbon dioxide emissions goes down. This means that emissions themselves are not actually decreasing in the countries that are receiving finance, but they're growing at a slower rate than they would be if those countries weren't receiving climate finance. This is a good thing. This is what we were looking for. Climate finance is an effective mechanism to reduce the growth rate of carbon dioxide in developing countries. But because it's not causing emissions to go down, allocations simply just are not enough. Climate finance needs to be scaled up and scaled up urgently. What we concluded here is that climate finance is a critical tool to both fight the climate crisis and improve sustainable development outcomes to bring about a better future for us all. Thank you.
questions for Indrani?
Indrani, that was great. I know you did this with an Earth and Environment professor, but how do you think also being an IR major kind of either helped you through this or gave you like a unique perspective on it?
Yeah, great question. Thank you. So going into this project, it kind of took me a long time to arrive at the idea of what I actually wanted to do, but I knew that I wanted to combine something that both included my environmental policy major and my international relations background. And looking at things like sustainable development is really like one of the best ways to do that because it considers how countries around the world can continue to grow in a way that is sustainable for both people and planet. So going into this, I kind of wanted to combine those two things and decided that looking at climate finance was sort of the perfect way to do that. And I think having like a bit of an economics background along with just sort of a more global understanding really helped me apply everything that I did here.
All right, if there's no more questions, good job, Indrani.
Thank you.